Hi, I'm Alka, and welcome to a tutorial on how to make custom objects in Super Mario 64 Decomp. So, a custom object in Mario 64 is generally defined as a object with a custom behavior. So that's what we'll be making today, and specifically we're going to end up with a platform that moves up and down. So yes, let's get started. We're going to start today in behavior-data.c, which can be found in the data folder. It's right there, and this is a very important file. This contains every single behavior in Mario 64. Like right here is the snippet. So each of these behaviors is what the game points to initially start an object. So when we go over to Blender and we add an object to the level, and we're going to be assigning it one of these behaviors, one of these names right here, and it's going to start by reading this code here of whatever behavior we are pointing it to. And today we are making a custom behavior. So we're gonna start typing that out. And we're gonna make a moving platform. So let's just call it moving platform. So fun. And now we have made a behavior. Would you look at that? So we have now started typing this out, and there's a few things to add here. So you can pretty much just look at any behavior that's already in the game. Like, because this is going to be a platform, we're gonna want a specific list for it. Specifically the surface. So as you can see, like the iRock boss in Mario 64, the hand is like a physical platform that interacts with Mario, like he gets pushed by it. It is a surface. Here's another Dory, like Mario could ride on top of Dory, that is a physical surface. So we're gonna be wanting the surface list type because this is gonna be a platform that Mario stands upon. And we're going to be wanting some flags here. So this is just a simple one that we're gonna grab for this. The next thing we're gonna be defining is the collision data. So obviously we want our object to have some kind of collision. And right now we don't have a custom model in Mario 64 yet, so what we'll be using for now is we're gonna be just using the middle box, the one that's pushable, obviously right here. So we're gonna give it the pushable middle box model, and we're gonna give it the collision to be able to test our object before we add our own custom model. It's a very nice model to use for testing before you add your own, just to test out the behavior. This one is just generally useful. Set drawing distance. Makes it visible when it's far away. It, like for performance, you may not want this, but generally if you're not aiming for anything for compatibility and you just want things to look nice, this is nice to have in your object. And that is about it in terms of the setup. We're gonna make a loop here, and so the loop's gonna begin and it's going to end. And make sure you have comps at the end of each of these so Decomp knows that you're moving on to the next line. And this, so all these functions here are gonna be ran when the object is spawned in, but the loop will be done infinitely while the object is spawned after the first things are done, because it's after. And we're gonna do a call native here, and we're gonna be loading load collision model. So right here, we're setting the collision model. We're saying this box, this moving platform is going to use the middle box collision, but it just says what it's going to use as its collision model. It's not actually making the collision happen. It's just saying this is what will be used. This line right here is what's actually causing the box to make sure that it always has that collision model. So it's always going to be interacting with Mario when Mario touches the box. Now, we're not quite done yet with our initial setup of the behavior, because we actually need to add this, because right now it's just, we type this up, but it's not actually defined in the game yet, and so when we make the ROM, it's not going to have any idea what this actually is. So we need to define it here in behavior data.h, which is found in the include folder. Include, and it's going to be behavior data.h. And we're just going to copy one of these and copy our behavior name here. So now it's defined in behavior data. And that's modified now. Both of these are modified. And now we're going to go and hop over to Blender. So this is just a quick 3D model that I whipped up for this tutorial. And this is our level. And we're going to be adding our custom object to it. So we want to go to add in Blender, and we're going to want to add an empty. And you can use any of these. I prefer the cone because it clearly shows which way it's going to be facing. It's just nice in my opinion, but you can use whatever you want. So you can be moving it around, and we're going to be placing it here. Yes. And so this will be our object. We can rename it to whatever we want. Since it's moving platform, I can just call it a moving platform. This doesn't really matter. We're going to be moving this inside of our level. So move over here, hold shift, and drag it on top of area 1. So it's in our level now, in area 1 of our level. And we're going to want to set this to an actual object. So just go down to here, inside moving platform, to the object properties, and set the object type to object. And now we get set its properties. So we want it to be the metal box model, but we're gonna want it to be our custom behavior, which is behavior moving platform. So that is about it for that. We have now added our custom object. It's that simple. So by hitting this little arrow here, this pops out, and we want to make sure that our decomp folder is selected, and I'm going to be exporting this to Bobomb Battlefield. And now, with our level exported, with our custom behavior, we're going to make the ROM and see it in game. So we're in Mario 64 now, and loading into our level. Here is our custom object, and it's just as we made it. It is just a metal box, and we didn't have a custom code assigned to it, so that's all it is. It's just a metal box, and Mario can fully interact with it and everything as the collision metal box as the model, but no custom code yet because we have not added that yet. So yes, it works so far. And now back in Visual Studio Code, we're going to make some code. We're gonna give this box some properties. So let us go and do that. Now, to do that, we're gonna need to make a new file. Now we don't necessarily need to make a new file, but it's nice for organization purposes to do this. And this new file will be in src, game, and behaviors. So this is where all of the actual code for the behaviors are, because this stuff right here in the initial calling of each of the behaviors isn't, you can't do a whole ton with it. So we need the an actual separate file to be able to do more interesting things. So we're gonna be making a new behavior here, and we're just gonna call it moving platform .inc.c. So we have a new file here, completely new for us, and like how we did here, how we had to define this, we also have to define this file because this file is completely new. So we have to go to src game and then object behaviors dot c. Here it is. So right here there's a bunch of includes at the bottom, and these are a bunch of the behavior files, and we're going to be adding one more, and that being the one we just made. So now it is defined there. Now back to our moving platform. We're going to be making some code here. So this is how we're going to start. It's very similar to what we did before. This is going to be a void function, and we're going to be calling this function in our behavior data. And we're just going to do something really simple right now. We're just going to make the object go upward constantly. So this is what I just typed out here, is the object's Y position. So the O stands for the current object. So we're looking at the current object that this function is applying to, which will be the moving block. This should be moving platform. My apologies. It doesn't really matter though. But this will be the moving platform, and this is the moving platform's Y position. Of course, this is X and Z position. And in Mario 64, the Y position is up and down, which usually is the Z position in 3D model viewers and in 3D games, but Mario 64 flips the Y and the Z. So it's just funky like that. And we will be making it go upward like this. So every frame that this is called is going to move up 4 units, and that's it. We're going to see if this works. Something really simple. But to be able to do this, we're going to need to make sure that this function is loaded here. And to do that, we're going to be typing extern, so external, void, is in our behavior, moving platform. So this will be called here. It's not loaded in, and we gotta make sure that the called native down here is calling it, because we want that function to be called. So same thing, behavior, moving platform. And now it shows up here because we have loaded it in. So this loads it into this file. This calls it during actual gameplay, during the loop. So now, if we build our ROM again, the platform should move upward. So in game, we can see that our block is moving upward. That little platform is rising every single frame. Now, this isn't particularly useful for designing a level, so we're going to change the code a little bit, but now we know that it works. So in Visual Studio Code, we're going to go back to our code here, and we can just do whatever you want. But I will be showing you some important commands and just different things that are important for you to know in terms of coding in Mario 64. So a lot of these are just gonna be like normal C functions. One very important function is switch, which we'll just type up the whole thing first. So switch and object's action, and we're gonna have two cases, case 0, and that's gonna break, and case 1, and that's also gonna break. It should be. Now what this is gonna do is that it's gonna switch between these two cases depending on the object's action state. And object's action state is specifically designed for our purposes right here. It is a variable specifically for changing in object's state. And we're gonna want this object to be in two states because, like I said earlier, this is gonna be a platform that moves up and down. So state 0 is the object moving up, and state 1 is going to be the object moving down. So let's go put this into our first state. So by default, it's going to be a state 0. So it's going to start by going upward, and then we're going to have an if statement, and we're going to check something. We're going to check the object's Y position. But what are we going to check it with? What kind of thing are we going to be checking here? Well, here's another very useful thing. So generally, let's let's check if the object's Y position, let's say, is at a certain height above where it started. Let's say 100 units. So if we were to type out something like that, so it's like greater than or equal to, it should be inside the parentheses. If it's greater than or equal to the start plus 100. However, what is the start? What is the object's start position? What variable do we use with that? So in Mario 64, it actually has a function that does this for us, which is very useful, and it is called set home. So in our initial behavior here, when it's first called, we're gonna add something, set home, and this will set the object's home, obviously, and the home is the object's starting position. So whatever coordinate the object starts at will be marked down in his home. And now that we have stated that in the right here, when the object's first called, we can now access that value now in our code. So that value is object home and then the position. So we're going to be comparing the Y position here. So the object starting Y position is going to be this. So we're going to check if the object's current Y position is 100 units above its initial Y position. So pretty much if it's moved 100 units. And if it has, we will say equal to 1. And so the object action, now it's going to be 1. So this is no longer true. It's no longer case 0. It's now case 1. And pretty much we're just going to do the exact same thing but in reverse. So we're going to make the Y position go down 4 units every frame. And we're going to check if the Y position is just less than or equal to its initial position. Right? Because, if it's back to where it started, then it should go back up. That makes the most amount of sense to me. And we're going to make it go back to its original case, 0, so it's going to go back up. So it's going to go up, reach a certain point, go down, reach a certain point, go back up, and just continuously do that. So that's what this code will be doing. So using switches in cases with the object action is very useful. You could do a lot of stuff with this, just having an object have multiple states. This applies to pretty much everything. So it's something very useful to know. And of course, if statements and homes, all very useful. You should know all this stuff. And now that you do, you'll be able to do a lot more. So let's test and see if this works in game. So now, as we can see in game, the object, the box, it moves up and down, which is exactly what we wanted. So it moves up 100 units, and it goes down 100 units. And Mario is able to fully interact with this box. This is our custom behavior, and you can modify this to whatever your heart desires. But now, we have one more step with a custom object. And what is a custom object without a custom model? So we're gonna hop back over to Blender here. So in Blender, I made just a simple platform here. And with this platform, I will be exporting it. So here in the tabs, there's gonna be two things you have to export. First is the collision. So we're just gonna call it moving platform, and it's gonna be an object in a level instead of an actor. So this is gonna be a level specific object. If you want it to be global, actor makes more sense. If it's been like an enemy that's gonna be appearing throughout the entire game, or just some kind of collectible, that's more what an actor is. Level data is more like just a platform or something very specific to a certain level. And this is going to be just a platform in Bobomb Battlefield. So this works perfectly fine. And just name it something, probably like everything else we've done, moving platform. We're going to make sure we're in object mode and have it selected. So we export the object, and the other thing we have to do is the geo layout. And this will be the actual visual model. So here's the collision, this is what Mario is going to be interacting with, this is what we will be seeing in game. So very similar in Bobomb Battlefield, name it something consistent with everything else we've done so far, moving platform. For the folder, and now for the actual file, you want to make sure that it's also consistent, but also has this underscore geo at the end. That's very important. And we just hit export object geo layout. Armature is like for animations. So now it's fully exported. Back in Visual Studio Code, we have some very important stuff to do to get this model working. The first thing we have to do is add an actual model ID for it. So here we have the model IDs.h, and in this folder, well, in this file, we're going to be adding a model ID for our object we just made. So you can see a bunch of IDs here specific to each of the groups, specific to each of the levels, and we're going to be adding our own ID. So if we look at Bobomb Battlefields, we can see it uses IDs 36, 37, 38. So yeah, like, those are the ones that it uses. So we're going to be using 39, so we don't overwrite 36, 37, or 38, because in the game will not like that. Because there's already objects in the level that have those IDs. And we're just going to call it model moving platform. And that will be our object name. And model IDs is an include, by the way. Model IDs.h. So after adding that to this, we head over to script for our level. So this is located in our levels folder. Look in levels, and we replace Bobomb Battlefield, so this would be where we're heading. And script.c. This is the main level script that loads the objects into the level. And this is very important because we have to load our model. You can see that all the other models specific to the level or here. So like this is the tree, and these are just specific level models, being the gate, seesaw, bars. We'll be adding our own little platform here, using the same model name we just typed out, model moving platform, and we'll be using the moving platform geo. So this is correlating the geo to the model name here. Very, very important. And the last thing we have to do here is have our collision. So the collision is already loaded if you like look around the files, but it's not loaded with our behavior here. It's still using the metal box. So all we need to do is just change this to moving platform collision. So now it's gonna load our collision for the moving platform instead of the metal box, which is obviously what we want because we made this. We made the collision specifically for our behavior here. And now we head on back over to Blender to add our object in. So back in Blender, we can select our object, and before we had the model metal box, we're gonna have a custom model now, and we're gonna want to name it exactly what we named the model name, the model moving platform, where we assigned the geo to in the script.c. So because the geo and this model ID are linked, the geo will be loaded when the ID is read here. And that's all we need to do. So export level once more, and let's open up Super 64 one final time. So in the game, we can see that our custom model is right here, and it has its proper collision. So it's all circular. It is not a box. And yeah, that is a custom platform that moves up and down. So, I hope you enjoyed this tutorial of how to make a custom object in Mario 64 Decomp, and I hope you found it helpful. If you have any questions, feel free to ask me in the comment section down below.